Have you ever wondered what it really means when people say agentic AI? You've probably heard terms like chatbots, assistants, or LLMs being thrown around everywhere. But agentic AI is the next big step beyond that. Imagine an AI that doesn't just wait for your command, but can actually decide what to do next, plan ahead, take actions, and even use tools on its own. Instead of being like a calculator that just gives answers when asked, an agentic AI acts more like a digital intern. It understands a goal, figures out the steps, and works towards it without constant human guidance. For example, you could tell it, organize my research on climate change, and it would go online, collect sources, summarize them, and maybe even build a presentation, all automatically. That's the main difference. Regular AI responds while agentic AI acts. Now, how does it actually work? The heart of agentic AI is still a large language model, LLM, like the kind that powers chatbots. But on top of that, it has a few extra layers that let it reason and retrieve information in real time. One of the most important parts of this system is something called RAG, short for Retrieval Augmented Generation. That might sound fancy, but the idea is super simple. Think of the AI's brain as a student's mind. A regular LLM is like a student who learned from all their textbooks but can't open new ones during the test. They rely only on what they already remember. But an agentic AI with RAG is like a student who can open the textbook mid exam, look up fresh information, and then use it to write a better answer. Here's how RAG works. When you ask the AI something, it first retrieves relevant information from an external source, like a database, document, or even the internet. Then it uses that information to generate a response. So the process has two steps, find and write. This makes the AI smarter, more accurate, and better at staying up to date. For example, if you ask it about the latest iPhone, the LLM alone might not know because it was trained months ago. But with RAG, the agent can pull in recent info and combine it with its reasoning to give a current answer. This is the backbone of most modern agentic systems. They mix stored knowledge with live retrieval, which makes them feel more alive and useful. But even though that sounds perfect, agentic AIs aren't flawless. Like all systems that learn from data, they come with biases. And sometimes these biases can shape their decisions in ways we don't intend. Let's take a simple example. If an AI is trained mostly on English text from Western countries, it might unknowingly favor Western viewpoints, ignoring other cultural perspectives. Or if it's trained on job data that shows mostly men in tech roles, it might accidentally assume that men are more likely to be programmers. These are not intentional mistakes, they're side effects of how the AI learns patterns. Bias in AI comes from bias in the data. Now, when we talk about agentic AI, these biases become even more important to address because, unlike a regular chatbot, an agentic system doesn't just say things, it does things. If it's biased while summarizing articles, that's annoying. But if it's biased while hiring people, filtering resumes, or recommending medical options, that can have serious consequences. So, part of building good agentic systems means building checks and feedback loops, ways for humans to review its actions and guide its learning. Some new models even use self correction methods where the AI critiques its own output before showing it to users. Think of it like an internal conscience that tries to keep things fair and logical. Now let's talk about applications, because this is where things get exciting. Agentic AI is already sneaking into our daily lives, even if we don't notice it. In offices, it's becoming a smart assistant that can schedule meetings, write emails, and summarize long reports without constant instructions. In education, it's helping students by breaking down complex topics, generating quizzes, or even acting like a personal tutor that adapts to your learning style. In science, researchers use it to automatically scan hundreds of papers and pull out useful data, something that would take humans weeks. Even in art and design, it's starting to plan projects, gather references, and help artists explore new ideas faster. Some companies are going even further. They're building AI teams where several agentic systems work together like a group of coworkers, each one handling a specific task like research, planning, or execution. They can talk to each other, share data, and collaborate on projects with almost no human micromanagement. Imagine a group chat, but every member is an AI specialist doing their part. This kind of setup is already being tested for software development, marketing, and even film production. So, what does all this mean for the bigger picture? The road to AGI, or artificial general intelligence? Well, agentic AI brings us a major step closer. AGI is the dream of having a machine that can understand, learn, and act across any field of knowledge. Basically, intelligence that's flexible like a human's. We're not there yet, but agentic systems are showing the early signs of that direction. By letting AIs plan, reason, and adapt using real world data, we're moving from static intelligence to dynamic intelligence. The moment these systems can fully understand context, correct their own biases, and independently learn from outcomes, we'll be standing at the edge of true AGI. So, friends, when you hear agentic AI, think of it as the first generation of doers instead of just talkers. They're not just answering questions anymore, they're figuring things out, making plans, and taking steps toward goals. And while we still need to guide them carefully, teaching them fairness, responsibility, and balance, they're already hinting at a future where intelligence isn't just artificial, but genuinely active. And that, perhaps, is the most human like thing we've built yet.